In this video, we will talk about the secant and cosecant curves. So we've learned how to do the sine and cosine curves. The secant and cosecant curves are not that bad. So, for example, if we want to talk about the cosecant curve first, well, that's just basically the sine curve flipped. So if I talk about this as 0, pi over 2, pi, 3 pi over 2, and then 2 pi, well, let me first start off by graphing the sine curve. Okay, so the sine curve is going to look like this, starting at 0, 1, 0, negative 1, 0. So the sine curve looks like this. And when you remember about the cosecant is a reciprocal of this. So basically what you're doing is that you're finding the asymptotes first, and the asymptotes are going to be where it crosses 0. Because remember, this is just equal to 1 over sine of x. So wherever sine is 0, that's where you're going to be undefined, and you're going to find asymptotes. So you have an asymptote at 0. You have an asymptote at pi. And you also have an asymptote at 2 pi. And basically what you're going to do is just flip these bumps. So see, here's the bottom part. You're going to flip it upward. And here's this bottom one. You're going to flip it downward. So here, the cosecant curve, without the reference graph of the of the sine, is 0, pi over 2, pi, 3 pi over 2, 2 pi. So I'm going to draw the asymptotes again. Okay. And then at 1 and negative 1, you're going to have the bottoms of the parabolas. And these parabolas are getting closer and closer to the asymptotes, but they're never going to touch it. Okay, so they kind of look like this. All right. So later on, we're going to talk about the domain and the range. The range is pretty easy. To find the range is pretty basic. You can just see that the range is going to be from negative infinity. So notice that this is going to keep going down from negative infinity all the way until it reaches to this point, negative 1, which includes it. Then you see nothing in the inside because that's where the sine wave was. And now it's going to start off again, union 1 all the way to infinity. So this one actually isn't that bad. Okay, it's the domain that's a little tricky. And later on, we'll talk about the domain. But for right now, this is how you're going to write it in sub-builder notation. All values of x such that x is not equal to pi k. And here k is an integer. Let me write it over here. So let me just write it like this. And then here k is an integer. Okay, and usually we can write k as an integer as this. K lives in z. Okay, so let me explain this a little bit. So this is what we call sub-builder notation. So whenever you see x such that x is not equal to pi k, this means x, this means such that, and then here x is not equal to pi k. This thing, k, this is just k, obviously. This can say lives, or you can say it's an element of. Okay, that's just basically what that means. And then this z thing is what is the integers. Okay, all possible integers. Integers, remember, are numbers that are negative 2, negative 1, 0, 1, 2. These positive and negative numbers. Okay, later on, we will be able to find the equation of the asymptotes and finding the domain of this. Right now, we'll just take a little pause of the domain and the range, and then we'll come back to it. But right now, you can easily find the domain of it. The domain, if you see, is where all the asymptotes, so it can be anywhere except the asymptotes. So x can't be where all the asymptotes are at. Notice here, the asymptotes are every pi units. So that means every pi units, you're gonna get an asymptote. So that's why you have this pi k. This k is every multiple of the asymptote. So if I want to know what is the domain, or where's the next asymptote after 3 different cycles, then you can just choose k to be 3. Okay, well, not really cycles, more like 3 asymptotes, like the third asymptote. Okay, so this is basically the domain and the range. We'll talk about these a little later after we finish graphing all of the trig functions. So that's a cosecant. This is kind of how the cosecant graph looks like. Okay, now let's look at the secant graph. Okay, so f of x is equal to secant of x. So what does that guy look like? As we know that secant is the opposite of cosine, we're going to start off by drawing the cosine graph as a big X. Okay, so we're going to start off by drawing the cosine graph. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So here's 1, here's negative 1. So cosine always starts at 1. So this is kind of how this guy looks like. Okay. So now what we're going to do is do exactly what we did. So the asymptotes are going to be wherever cosine is 0. So that's at pi over 2 and at 3 pi over 2. Okay. And then everything else we're just going to flip. So flip. So to make it a little nicer, we can see that you're going to have 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then the asymptotes is here at pi over 2, another one at 3 pi over 2, and then at 1 and negative 1, we're going to have these parabolas. Okay. You can kind of see that they're kind of alternating up in the sky. So the domain for this guy, notice that it shifts over pi over 2, but it's still every pi unit. So it's going to be all values of x such that x is not equal to pi over 2 plus pi k. So we're adding a unit of pi over 2. This is called set builder notation. I don't know if I said that, but this is called set builder notation. So let me write it down. Set builder notation. And that's because it's really difficult to write it in interval notation with the asymptote. So it's better to just write it as a set builder notation. And here the range is basically the same as before. Negative infinity to negative 1, union 1 to infinity. Okay. Again, don't worry so much about the domain just yet. We'll talk about the domain later. Okay. All right, so that's the secant curve. So basically, if you want to draw the sine and the secant or the cosecant graphs, the first thing that you want to be able to do is graph the cosine or sine curve. So graph cosine or sine. So it really depends on which one you have. So if you have secant, you're going to graph cosine. If you have cosecant, you're going to graph sine. Okay. And then I'll put here, look for asymptotes. So look for the asymptotes and flip to form parabolas. Okay. And then at the very end, do vertical shift at the end. Okay, so you want to do the asymptotes and flip the parabolas first before you start doing the vertical shift. The vertical shift, you want to do it at the very end. Okay. All right, so let's go ahead and start. Let's do 2 problems since most of these problems are not really that bad. So graph. So let's say we have f of x is equal to 3 cosecant of 2x plus pi plus 1. Okay, so let's say we have something that looked like that. So instead of graphing the cosecant curve right off the bat, instead what we're going to do is we're going to graph the reciprocal of cosecant, which is sine. So we're going to graph 3 sine of 2x plus pi plus 1. Okay, so we're going to do that. And remember, we have a vertical shift right here. This, we're going to save it at the end. All right, so let's start off by drawing this guy. So first, let's start off with a phase shift. We know that x is going to be between 0 and 2 pi. So we're going to have 2x plus pi. So we're going to have 0 here and 2 pi there. We're going to start off by subtracting pi to all 3 sides. So we got 2x is between negative pi and pi. Then we're going to divide by this by 2. So x is going to be between negative pi over 2 and pi over 2. All right, so now let's go ahead and graph this. So, oops, that's wrong. So I need some negatives, some positives. So here's negative pi over 2, and here's pi over 2. The midpoint here is 0 because obviously it's halfway in. If you want to find the midpoint here, you're going to take negative pi over 2 plus 0 divided by 2. That's going to give me negative pi over 4. And because of symmetry, the other one should basically be pi over 4. Okay, so we got kind of lucky. So now notice that let's kill two birds with one stone because we see that there's a 3 there. So we're going to multiply all the y values by 3. And because it's a sine curve, we're going to start at 0. So 0, then 3, then 0, negative 3, 0. So the sine curve has the same shape. It's just going, whoops. The sine curve has the same shape. It's just going through different points. All right, now let's not do the 1 yet. Let's flip it first. Okay, so we're going to draw the asymptotes first. So we have an asymptote right here, have an asymptote right here, and I have an asymptote right here. And what we're going to do, we're going to flip everything over. Okay, so basically my graph should look something like this. So negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. So I have my vertical asymptotes right there. And then at 3 and negative 3, they look like this. Okay, so that's basically what they look like. Now we're not done yet, okay? That was helpful. So we got basically the cosecant curve. Now what we got to do is just shift it up 1 unit. So now we're going to shift it up 1 unit. So 1, 2, 3, 4. Negative 1, negative 2, negative 3. So here we have negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. So my asymptotes are going to be at negative pi over 2, 0, and at pi over 2. And then I'm going to shift this guy up 1 unit. So now this guy's at 3. I'm sorry, at 4. It's going to go upward. And then this guy is going to be shifted up 1 unit. So now it's at negative 2. So it looks like this. So this is going to be my graph, the cosecant. Okay. Alrighty. So now let's do one last problem. We'll do the secant one. So let's say we had, not y. We're dealing with functions. G of x is equal to negative 4 secant of 3x minus pi over 6. Okay, let's just say that we have that. So again, because we don't want the secant curve, we're going to graph the cosine curve, 3x minus pi over 6. So let's start off with the phase shift. So we know that the cosine curve is between 0 to 2 pi and completes 1 cycle. We're going to put in 3x minus pi over 6 in the inside, 0 to 2 pi, and we're going to add pi over 6 to both sides. So you're going to have 3x. This guy's going to give me pi over 6. This guy is going to give me, I don't know, something. Okay, so 2 pi plus pi over 6. You're going to get 13 pi over 6. And now we're going to divide by 3. So you're going to get pi over 18 less than or equal to x less than or equal to 13 pi over 18. Okay, so these numbers are a little bit more uglier than before. So now let's go ahead and graph this. So we're graphing the cosine. So we're starting at pi over 18 and we're ending at 13 pi over 18. All right, so let's find the midpoint. So 13 pi over 18 plus pi over 18 divided by 2. So we're going to put it in our calculator. 13 pi over 18 plus pi over 18 divided by 2. That's going to give me 7 pi over 18. So that's going to be the inside. Now we're going to look at this guy. So pi over 18 plus 7 pi over 18 divided by 2. So pi over 18 plus 7 pi over 18 divided by 2. I got 2 pi over 9. And then we're going to do 7 pi over 18 plus 13 pi over 18 divided by 2, which is going to be this last one. 13 pi over 18 divided by 2. That's going to give me 5 pi over 9. Okay, good. All right, and now all we got to do is just look at the amplitude, which is going to be -4. So I'm going to multiply everything by a 4, and I'm going to flip it. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. And now everything's going to be flipped. Now, because it's a cosine curve, it usually starts at 4. Now it's going to be a -4, 0, 4, 0, -4. So the graph kind of looks like this. Okay, now remember, there's no vertical shift, so we don't have to worry about that. All we got to do now is flip it. So where does it cross 0? So it crosses 0 right here. Crosses 0 right here. So we're going to flip everything over. Okay, so let me just draw it a little bit nicer. So pi over 18, 2 pi over 9, 7 pi over 18, 5 pi over 9, and 13 pi over 18. Okay, so we have it at 2 pi over 9, and we also have it at 5 pi over 9. This is at 4. That one's going to go, I don't know where. This guy's going to be at -4. Okay, and then we have this last one at 4. And off somewhere it goes. Okay, so we didn't have to shift anything. Okay, so this would be your final answer. Okay, not too bad, as long as you know how to graph the sine and the cosine curves. Is pretty basic. And then we just have to flip the secant and cosecant curves.